Okay, we're recording now. Hi everyone, this is the weekly benchmarking tool sync. Today we can continue our discussion from last time. So last time we looked at the different options that we have and what are the different features that we want to incorporate. So we can. There were a few comments. So if there are any questions on that, we can start with that, and then we can go into the specific topics we have called out for today. I think Samuel, you had something there, and ZLM load test was also added by someone. If someone wants to talk about that too.
Yeah, so that was us. I'm from the Red Hat Performance and Scale team that is working on AI. We use our own in-house tool, which is LM Load Test, which is separate from FM Perf. This is just kind of historically, just because we didn't have FM Perf when we started doing the latency testing. But we see some minor advantages that it gives us in that it can be run outside of a Kubernetes environment. And since Red Hat has products both in Kubernetes and outside of Kubernetes, we kind of need that to cover both use cases. So we just added our tool here just to give a comparison between the existing ones on the sheet.
Okay, makes sense. Anything specific to call about the tool in comparison to others here? I see I've listed most of the things, and it seems like a Python-based tool, somewhat similar to FMPerf. Um, One thing you mentioned is being able to run outside of Kubernetes as well. Okay, cool.
We add that like being able to run outside Kubernetes into the tool.
Chen, you're really quiet.
Could you hear me better now?
The volume still seems to be pretty low. Yeah.
How about now?
Oh, much better.
Okay, I'm asking, should we add like being able to run outside of Kubernetes as a main feature in the table we want to achieve?
Yeah, we can add one more row for that.
Mm-hmm.
Um, and I think, yeah, it is something we need as well, because one of the goals is to have this as a benchmark as a code tool. So anyone should be able to use it as a library if they want, or be able to point to any inference server deployment if they want to run as well. Yeah,
I will go ahead and add it.
cool. Thank you.
Also, Chen, do you know where our load generator it goes into this picture? Like, does it come under the FMPerf or it, should it be at a separate column?
So right now, FMPerf has load gen, but together with FMPerf. And then Felix, do you want to introduce your load generator because it's not open sourced yet, right?
Yeah, it's not open source, it's internal.
Okay, I will take notes and feel free to introduce whatever you have.
Okay, so I have a slide. I have few slides. Do you think I can do it now, or should we wait for the next session? Or if you want, I can go now.
We can actually do it now too. Um, yeah, basically on the agenda we have yeah, a few topics. So I think Chen is adding one more there. So yeah, let's go. Let's go from the top. Yeah, so Yeah, we just discussed updates since last meeting. I think, yeah, one more tool and a new load tester to discuss. And we have the different options for comparison here. If like being able to run outside of Kubernetes, if there are other options you would like to see, feel free to add that as a row here so we can discuss that too.
Uh, yes, so actually Felix is also from IBM. So internally we have something to be able to run with FMPerf supporting supporting uh, the RPS, the dynamic RPS. And
Okay.
so right now that part is not open sourced, but Felix would like to contribute to upstream in the future when we have the project set up. So he can introduce a little bit, like 1 or 2 slides on what exactly it is and how it works right now.
Okay, sounds good. Um,
Felix, feel
yeah,
free to
Felix, do you
take
want
it.
to
Yeah,
Yeah.
okay.
present?
So can you give me the permission to share? Like,
Yeah,
I have a slide.
so I just made you the co-host if you want to try now.
Okay. One second. Okay. Whom is asking me to quit and reopen? Chen, can I share you the slide deck?
Definitely. Send it to me. Yeah.
Yeah, just sending. Okay.
Are you able
Uh,
to see the
yes,
slides?
yes, I can see. Can you go to the slide number 2?
Mm-hmm.
Okay. Yeah, so these are the basic configurations and capabilities of our load generator. Like we support both TGS and VLLM. And it has 2 modes of load generation. The first one is async mode. So async mode follows a request per minute. Uh, like so we are not using request per second. It was too coarse for us. So we were using request per minute. And the second one is the batch mode. Okay, I will explain the async mode first. In async mode, you will generate k request. Okay, so the number k that can be sampled from a uniform or a Poisson distribution, and all the k request generated will be.
Felix, maybe with the next in the next slide you have the picture, right? With
Oh
it's
yeah,
help you
okay.
can explain better.
Okay, okay. The first one is the async mode. So in this configuration, like you can have multiple users, and each user can have their own request rate and request rate. Okay, so at each iteration, k request will be generated by the load generator, and it will be sent in a duration of 1 minute to the inference server. So that's how it follows the request per minute criterion. Okay, and there is a sleep time between the successive requests, and the whole sum of the sleep time will come to around 1 minute. Okay, and the k here is sampled from the Poisson distribution or uniform distribution. It is configurable, and the sleep time between the request is can be sampled from either an exponential distribution or uniform distribution. So these two things are configurable. And the second one is the batch mode. So here also the number of requests is being again sampled from a Poisson or uniform distribution. We are planning to add more distributions in the future. And it will send all these requests together. And it will keep on waiting for the response. So it will wait till all the request in the batch will get a response. Okay. So the batch mode kind of waits for all the response, and the async mode doesn't wait. It will follow the request per second. So can you go back to slide number 2? Okay. So here we also have some criterions like token latency. So token latency, like it is for configuring timeout for each request. So we considered the timeout. We decide timeout as token latency times the max new tokens to generate. So after that, we gets out of the like we consider the request being failed. Okay, and we also can configure the output token length. It is being output token length can be set as variable or fixed. If it is variable, we take it from the uniform distribution from max and min token length in the configuration. Also, in VLLM, we can customize the number of prompts in one request. So that's also added here. Yeah. So this basically covers everything regarding the configurations. Do you have any questions?
So with the async mode, you are saying
Yeah.
each user sends a request, but they don't wait for the response to come. And based on whether it is Poisson or uniform distribution, you would keep on sending more requests at
Yes.
specific intervals. Is that right?
Yes. 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 Correct.
That's good to know. And
Ashok, so is your use case, does that cover your use case you want to support?
yeah, so for us, I think currently we are using a Poisson distribution uh, to send specific RPM or RPS. So I think that covers it. And the uniform request rate distribution would be something that is useful too. We have explored that before, but haven't added that. It would be because usually with Poisson just keeps on varying, right? Um,
Yeah.
with the uniform one, we could maintain like the exact set of requests per second or minute, which would be nice to have.
Yeah. So yeah, and
And
can
this
you go?
is in Go, coded in Go, right? That you have.
Yeah. So yeah, like it's a small contain image which we so you can either give the service uh, service IP or the container IP of the LLM instance.
Okay.
So can you go to the 4th slide?
Mm-hmm.
So like this is our setup for running the LLM based experiments. So we have an OpenShift client, so which can deploy the load generator code in different configurations. So it's basically the automating the process. And once the experiment completes, we will download the metrics from Prometheus. So this is the whole.
Thank you, Felix. So Ashok, that actually leads to my first bullet point in terms of discussion I would like to bring to this community. So so FMPerf right now, the orchestrator mechanism itself can easily plug in different load testers as a job, right? Or a deployment on Kubernetes. So so whatever configurations, input data they can take. So those parts are flexible. So but in order to make FMPerf able to be compatible for all different types of load testers, we need to unify the output, the way to collect the data. So, for example, like Prometheus is one, but there are some statistics we do want to collect from the client side, from the load tester client. And then what should be that, and what should be the standard for those output data? And then so that's something we need to discuss. So right now, for example, like, do you have some experience in terms of like how you collect data from your latency profile generator?
Yeah.
So I guess that's like, oh, go ahead. Go ahead.
No, go ahead, Sam. You can finish. Yeah.
Oh, I was just going to ask a question. So I'm not too familiar with FMPerf, but does it do metric collection from the inference server rather than relying on the load test generator to kind of aggregate those metrics?
So actually we have to, so it can fetch the data from Prometheus, for example, that is exported by the server itself, inference server itself. And then we have some other mechanisms to mount the persistent volume to the job pod and then collect the statistic or summary from the client side. So we have both. However, we don't have a standard saying like what types of metrics are necessary for all the load testers to provide. So, and we don't know if like mounting a persistent volume is always a good way, and how we support, for example, different cloud environment.
Okay.
Cool. I need to take a quick call. Something urgent came up, so I'll join back in a couple of minutes. But yeah, feel free to capture some of the discussion.
Sure.
Okay, so in that case, I can just throw out some metrics that we like to capture, which is like time to first token, intertoken latency. If we can't capture intertoken latency for non-streaming responses, we prefer time to output token, time per output token. But there's some variance in how you can calculate all of those. I would be interested in just hear how other people here calculate it, if they measure time per output token, or not time per intertoken latency per token or per request, or average on per request, and then extrapolate that to metrics around each request.
So one question. So here, how do you define the intertoken latency? Like, are you using the Prometheus to get the metrics? Like, for example, LLM provides it, right?
So LLM load test, what we use, it does all of the calculations client side. So we have multiple different inference servers we need to test against, and we can't rely on any individual server to provide those metrics. So the way we calculate it is intertoken latency is the time between each token, excluding the first token.
Okay.
But then how can you do it precisely sitting at the client? So can you share the formulas or the method that you're using to compute these?
Yeah, it's all in the code. It's all open source. But so officially right now, we are just doing an average intertoken latency over each request. So it's just time from the first token to time to the last token divided by the number of tokens in the request. We want to more precisely, this is what we're working towards, more precisely gauge like the 99 percentile of within the request versus just the overall all of the requests we make. Go ahead.
Yeah, I was just going to ask how you get the time to first token.
It's the time between the time between the request being sent and the response from the server.
But then that would include all the rest. So are you getting token? So when you get the response from the server, you're getting all the tokens back, right? Then
No,
how do you get?
this is only for a streaming scenario. So non-streaming, we cannot calculate time to first token.
Okay. Fine.
I see a hand from Abdullah as well.
Yeah, like we can also rely on the model server to report, for example, TTFT, even in the non-streaming case, and we can scrape those metrics. Now, for intertoken latency, we do have a canonical, like semi-canonical definition right now. I think NVIDIA, they have a page where they define those metrics, and it would be good to just be consistent in the community what exactly those measure. It is per request, and it is basically like the time. I think, Ashok, it's the time for decode divided by the number of decoded tokens, right? It doesn't include TTFT.
Yeah.
Yeah. It's the time
So-
until
So-
first of it.
Yeah, but from the client, you won't be able to do this, right? So you should scrape the from Prometheus.
For a non-streaming scenario, yes, you have to
Yeah.
do it.
Okay.
Yeah.
Yeah. So
Oh, go ahead.
we
Yeah,
have not
and for
done
the
this.
and for like and the other metric that we are interested in, like in general, it would be useful is the which we can do like from the client, which is like the total time spent to process the request divided by the number of output tokens, including the first token, but not including the input tokens that were processed.
Yeah,
So
that's what we
it
call
would be
time.
good to have a name for it. I don't think the community has
Yeah, okay,
it's not teapot. We've been calling it average output token latency.
Oh, okay.
But it would be good to come up with a name for that one too, because that one you can measure from the client side all the time, right?
And so,
Yeah,
sorry,
yeah.
what is the difference between that and Teapot?
It includes the pre-fill. Sorry,
It includes the
Oh.
pre-fill too.
Mm-hmm.
Yeah.
That metric is useful, I think, over many requests, but in isolation, its average output token latency can be questionable because you could have a large pre-fill and a small output, and that would look incorrect. But
And
over
also,
many
if you have
requests,
queues, if there is queuing, it would be the error can be high if there is queuing.
Yeah.
That's a good point. So this is the other thing I think we need. Like Ashok, do you know if Teapot? No, Teapot is not going to include it. Time to first token doesn't include queuing on the model server, or it's just the prefill.
It
So are you
includes
saying
queuing on the model server initially. Yeah.
Sorry.
It includes queuing on the model server.
Oh, it
It's
does. Okay.
basically, yeah, the time that the model server first receives the request until the first token is generated. Yeah. Including
so
queuing.
Arshak, that has to be monitored from the client side, right? So if you are monitoring from a server side, the TTFT only has the prefilling time and queuing within the server, not queuing outside of the server.
Mhm.
Yeah. Yeah, we do need to measure TTFT from the client side as well with streaming to get a full picture. Because we have seen cases where model server it reports is not entirely accurate, right, on what we see on the client. So some time might be missing. So yeah, we need to capture in the client side too.
Right, and in general, like TTFT is probably not really useful for cases where you're not doing streaming, right? Like, why would anybody care about TTFT if it's not a streaming use case?
Yeah, for non-streaming, I think it still provides some insights into how long we are spending before decode itself and queuing and stuff. But yeah, streaming it's more useful definitely. Yeah, and in terms of what we can measure, I think like we have a few things. One in the metric standardization talk, we called out the specific things that would be good to measure on the model server side itself, and the general metrics that are used to measure performance in for LLMs. So I can also share like how like our output looks today in the benchmarking tool, and we can discuss like whether it makes sense to measure all of those things, right?
Yeah, sounds good.
Yeah. Let me quickly share that. Are you able to see the JSON here?
Yes, yes.
Yeah, so we kind of report something like this today. Um, for each request rate, um, uh, we report the request latency itself. This is the end-to-end latency on the request. For each of these metric, we report min, max, mean, median, and P90 and P99 distribution. So we have the throughput, which is in output tokens per second. Um, we report the input and output length that was processed during this benchmarking run. And we also report, they're calling it teapot, but this is the metric that Abdullah talked about, which is total time broken down by total output tokens. And then we report some model server metric that we pull. So yeah, these are the main ones we are calculating. I think TTFT would be something that we need to add here, and also inter-token latency, right? So I would say those are probably a good set of metrics to start with. I can probably call that out in the doc, and then people have suggestion for other ones, we can include those too.
That looks very similar to what we collect today in FM Perf as well. So those are statistics. My question is, do we still want to include all the raw data as well? Like the TTFT for each request and the teapot for even each token.
Yeah, raw data, I'm not sure how useful it would be. Maybe it makes sense to dump them out in a file if someone specifies an option.
It can be useful if you want to do your own percentile calculations, like if you want to do 99.99% or something similar. Like it is valuable to have at least the raw numbers per request.
Yeah, agreed. Yeah, maybe we can give an option to dump the raw numbers too.
So are you good with like mounting like persistent volume for jobs to let the testers to just write those statistics, for example, a CVS file or JSON file in locally? We can support both CVS and JSON. That shouldn't be a problem.
Yeah, writing to a persistent volume makes sense. Right now we have an option to write to cloud storage, GCS, because we are running it on GKE. Yeah, maybe that can be something that for different providers, they can have a different option to upload to some blob store as well. But yeah, having a persistent volume would be a good starting point to run on Kubernetes itself.
So
Yeah. Go
just
ahead.
to add one thing, in our load generator, like we are trying to dump all the response. Like there is an option to dump all the response into a file, like in persistent volume.
Sounds good. Samia?
Oh, I was just going to add, I think, yeah, that's a good default to have, is starting with files. It'd also be possibly interesting to maybe later down the line add some integrations for popular metrics tools in the LLM community. Like AIM is used a lot for training runs and time series metrics. So possibly later integrations down the line with those kind of tools.
Yeah, agree. We can also emit these metrics to from EPS and have those be stored there too.
Samuel, could you add those tools you mentioned? I think I missed it in the notes.
Yeah, I'll add.
Okay, Ashok, I see you have the other two items. I think we already covered all the items I want to discuss here. And about
Okay.
proposal and contributors, do you want to bring that?
Yeah. So I think last time we discussed having a, sub-project proposal. So does that sound good to everyone to start this as a new sub-project in workgroup serving, and then we can start with the basic building blocks that we discussed. Maybe we can have that written down in detail as part of the project proposal, um, and then go from there.
Yes, I agree, and we should start that.
Okay. Yeah, I can probably start a talk and then can collaborate on there.
So is there any resistance from your team on just donating the entirety of FM work as a starting, or not FM work, FM perf as a starting point, or
No,
is there any?
everybody agrees.
Okay.
I haven't heard any objections.
Yeah, I think the main things we discussed were to start with the Python benchmark as a code library, right? And then expand to include different things. We would also like to um, bring the specific things that we support in our tool into this one as well. So yeah, I think like with FMPerf, a lot of the portions and there as it is today definitely makes sense. Yeah, we just need to figure out which portions we start with, and then we can expand to include other things.
Yes, yes. We can also actually start drafting something in the proposal. And
Yeah.
then now it's more clear. About contributors interested in contributing to the tool, people feel free to sign your name up. And last question is, do we want the orchestrator part, which is deploying the server, deploying the job, and collecting the metrics, apart from load generator or testers? Do we still want to make them one repo or two repo?
That's a good question, actually. One reason would be to like, we want to make the benchmarking library itself be independently usable if needed. So two repo might make sense in that aspect, where the code repo could be just the benchmarking library with the load generator and metrics collection and all that. Yeah, we could have the orchestration in the same one too, but if there is clear separation that someone can use it independently, it should be good. Maybe we can get thoughts from other folks as well.
Yeah, we would very much like it to be a separate piece. Orchestration is going to have to make a lot of assumptions on exactly how your environment is set up, and just to make it more flexible, we would prefer, I guess it doesn't specifically have to be in a separate repo, but we would want it to be a very optional component of the whole stack.
Yeah, I think that makes sense to me. Yeah, we want the tool to be independently usable. If keeping it separate makes it easier to achieve that. Then yeah, we can do that.
To clarify, I mean the orchestration component. I think the load test is the real value add here, sharing the just sharing the method we calculate all of our metrics would be nicer than having a standard orchestration method, which is a little easier to develop in-house.
So you're saying orchestrator to be very optional from the whole stack, right?
I have a question here. So, like in our case, okay, so here, like suppose someone wants to bring their own load generator here, like a separate image, and like, will the orchestrator be able to support the new image, given that the output metrics are standardized? Like, for example, if I have a new distribution which I want to test out, and I have a load generator image, can they bring in their own image and use the orchestrator and the framework to test it out?
Yeah, I think we can make it a requirement for the orchestrator to independently support different load generators and how we orchestrate the deployment of the whole thing, right? But I think we would still want a default load generator to be made available as part of
Yeah,
the repo itself,
okay. Yeah.
preferably in Python. Yeah.
And our like we wrote everything in Golang, and if it's an image or like if it's language independent, you can run it in. You can accommodate everyone, right?
I think so. From the orchestrator side, I think we should be able to accommodate your load gen in Golang too. Yeah. Sounds good. I think that covers all the topics. I would say, please add your name if you're interested in contributing. Then we can probably start a project proposal and figure out a starting point, where to host the repo and all of that, and then proceed from there. Any other topics or questions? Okay. Yeah, if not, we can end early and see you all next time.
Thank you. See you all.
Thank you. Bye.
Thank you.